Hello everyone. We come from Group 7. Now we will introduce Set-UID privileged program. Firstly, we will introduce what is a privileged program. The privileged program has a privileged process. The privileged process has access to some resources not generally available. For example, users want to read a password file that denies permission of the normal user and they need a privileged process to access that file. What a Set-UID concept? A Set-UID program allows the user to use the owner's privilege to run a program with temporary elevated privileges. Every process has two user IDs. They are real UID and effective UID. The real UID is the real owner of the process. And the effective UID is privileged of a process. When checking permission to access, they always based on the effective UID. In a normal process, real UID always equal to effective UID, and both of them equal to the ID of the user who runs the program. For example, in the seed lab, the user is seed which UID equal 1000. When a Set-UID process is executed, effective UID is no more equal real UID. They change to equal the program owner's ID. If the program is owned by the root, the program will run with the root privileged which UID is 0. A normal process has the effective UID equal real UID equal seed id equal 1000. When it wants to access this file, it is denied because the effective UID has no permission to access this file. When a Set-UID process is run, a real UID is still equal 1000, but now, the effective UID is equal root ID equal 0. Now the program will run with the root privileged. When the file checks the effective UID, it will accept to be accessible. How the Set-UID secure? The Set-UID program allows users have temporary privileges. But this is different from directly giving the privilege by using sudo command. By restricted behavior of users, similar to the example, Superman has a vacation, but he still wants to protect the world. So he needs a superperson to do those jobs. He left his cape for a superperson to wear. But he does not allow them to do whatever they want in case they do bad things. So Superman designed computer chips and put them on the cape so that superperson can just follow instructions to do the job. How to attack Superman code? Because of missing knowledge, Superman cannot assume that the user can only do whatever is coded. In this picture, the superperson needs to go to the castle to rescue hostages. In example 1, superperson Thin has to follow instructions that fly north then turn left. So how to exploit those instructions? The answer is, a superperson will fly belly up or leg first and head face to back. So Superman wants to fix this vulnerability. He codes other instructions for another superperson, fly north then fly west. So how to exploit those instructions? The answer is, we can put the magnetic field near the turning point. At that time, the computer will be affected by the magnetic field, so that it will change the direction of the compass inside the computer, then the superperson just fly to east instead of west. Next session, we are going to explore how to attack surfaces of Set-UID programs. We have 4 ways to attack Set-UID programs. They are using environment variables, using user inputs, using system inputs that can be controlled by the users, and capability leaking with non-privileged processes controlled by users. First, we will talk about how to attack using environment variables. The environment variables are name and value pairs. They can be inherited from the parent process. Behavior can be influenced by inputs that are not visible inside a program. They are the environment variables that can be set by a user before running a program. For example, a path environment variable, used by shell programs to locate a command if the user does not provide the full path for the command. In system function, when they are executed, they will call /bin/shush first. If we call system function with ls as the parameter, /bin/shush uses the path environment variable to locate ls. In this case, an attacker can manipulate the path variable and control how the ls command is found, so that their code is run instead of ls command. Now we will attack through the ld_preload environment variable. This attack using dynamic library linking. When a program is run, it will call some libraries that contain functions run in a program. When this program is run, it has two functions, printf and sleep. Both these functions are in libc.so.6. But if we write a source code like this, override the sleep function, and compile it to libmylib.so.7 as a library, then set ld_preload environment variable to this library. When we run this program again, it will call the doc7 library first, and find out the sleep function in here, then access the doc6 library to find the printf function. In this way, we can run our code. How to attack via user inputs. We will access this concept through an example. In this example, is the program with the ctl program. Its mean print the content of the file. This program using the system function with the command as the parameter. The command variable is set by the developer and argv is set by the user. So that command variable can be affected by the user input. With the input of the user, when running this ctl program, it will use the mechanism to split the user input with the semicolon is the delimiter. For example, ctl filename, new command. It will run in this way, run /bin/cat filename, then run new command. We run this ctl program. We want to access and read the content of the shadow file. It works normally, but when we use the input in the quotation marks and semicolon as the delimiter, it will be a huge vulnerability. Because with this technique, besides accessing and reading RR file, the program also runs the /bin/shush command.
Capability leaking often happens when privileged program drops to less privileged. Example, we open a file in a program, but we forget close it at the end of program, so after a program stops, it's still there and has a privilege or maybe redirects to another shell with a privilege of file descriptor that we open. Summary: capability leaking is when a normal user has privileges higher than he or she can have, maybe root privilege. Next, we will talk about Task 9 in Set-UID Lab. In Task 9, named Capability Leaking, we have a program that opens /etc/z file but don't close it. Use Set-UID to access bash shell. As you can see, a program call function open will create a file descriptor, but don't close the file after all. So the hacker takes advantage of this fault. A program doesn't drop privileges. He accesses bash shell with privilege of file descriptor. Here's our demo for capability leaking. We forgot how to edit to Z file. For more intuitive demo,
these are all tasks in our lab. All of these tasks are 100% like what we just represent. We categorized this lab into 3 parts. The first part is how to attack via environment variables. This part has 6 tasks. Task 1 is manipulating environment variables. In this task, we can print out all environment variables by using print-en versus and set or unset environment variables by using the export or unset command. Task 2 is passing environment variables from parent process to child process. In this task, we recognize that all environment variables of the parent process will be inherited by the child process. Task 3 is environment variables and executive function. Essentially, the executive function runs the new program inside the calling process. We are interested in what happens to the environment variables. Are they automatically inherited by the new program? Task 4 is environment variables and system function. This function is used to execute a command, but unlike executive function, which directly executes a command, system function actually executes bin, shish, and asks the shell to execute the command. Task 5 is the path environment variable and Set-UID programs, and Task 6 is the LD preload environment variable and Set-UID programs. Part 2, attack via user inputs. It just has one task, invoking external programs using system function versus executive function. And the last part is the last task, capability leaking. For all of these tasks, we had a demo and posted it to this link. All of the information, methods about the lecture, are based on this course, Computer Security. A hands-on approach. Your progress, Section 2, Set-UID Privileged Programs. Thank you for hearing our representation. Goodbye.